In this example, we're going to be graphing a hyperbola. All right, so let's take a look at this equation. We can clearly see that it has not been given to us in standard form. So just like all the other times, what we're going to be doing is completing the square to find the correct standard form equation of this. So the first thing that we want to do, just like always, is we want to group our x's and then group our y's. So I'm going to rewrite this as 4x squared plus 8x, and then I'm going to have my minus 3y squared. There's not another y to group with it, so that just stays by itself. And then the constant gets moved over to the opposite side, so that becomes a negative 16. So let's go ahead and complete the square, but first remember that your x squared coefficient always has to be 1. So before I can complete the square, I have to factor out that 4. So I have x squared plus 2x, and then I'm going to have some value here, minus 3y squared equals negative 16. So to complete the square, we take b, we divide by 2, and then we square it. So 2 divided by 2 is 1. 1 squared is 1. So let me plug in my positive 1. Remember, because this is actually being multiplied by a factor of 4, when I add to the right side, I'm adding 4. Alright, so now let's go ahead and factor this. This would be factored into x plus 1 squared. I have a minus 3y squared equals negative 16 plus 4 is negative 12. Now this might be looking pretty weird, but we're going to fix it so that we don't have some odd things happening. Remember that this always has to equal 1, so I'm going to just divide everything by a negative 12 so that I end up getting a 1 there. Alright, so now what I have is 4 over negative 12 would simplify to 1 over negative 3. Well, I don't want a negative in my denominator, so I'm going to put the negative in the numerator. So this is going to be a negative x plus 1 squared all over 3. Negative 3 over negative 12. Well, the negatives cancel out, so that's going to be a positive. And 3 over 12 simplifies to 1 over 4, so that's just y squared over 4 equals 1. So this might seem a little odd, and that's because the negative is out in front. So remember that in a hyperbola, we usually have a minus in the middle. That's because the negative fraction should go second. So I'm just going to rearrange this and write the positive fraction first, so y squared over 4, and then that negative becomes the minus in the middle. So now I have x plus 1 squared over 3 equals 1. Alright, so I want to sketch this, so I need some information. I need to figure out what my center is, I need to figure out what my A and B are, and that's all the information that we'll need to sketch. Alright, so let's go ahead and start figuring out all of that information. So my center. Alright, I have a center of negative 1, 0. And here's why. The center is always HK, and H is always with X, and K is always with Y, right? So this is the first part of my center, and the 0 that's not written here is the second part. So this is going to be a negative 1 because it's positive here, comma, 0. Alright, my A, remember that A is always the value underneath the positive fraction. So here, this is my positive fraction. If I rewrote 4 in squared form, that would be 2 squared. So A is 2. And then B would be the denominator of the negative fraction. So this is the negative fraction. And if I rewrote this in squared terms, I would have to do the square root of 3, right? That's how I got 2 here. The square root of 4 is 2. So this would be the square root of 3, which is just the square root of 3. Alright, now because we're going to graph this, let me just grab my calculator. We want to figure out what that value is, and we're going to have to estimate a little bit. So if I do radical 3, I get about 1.7. Okay, so that's kind of a mental note for us. You never want to actually write the value of b as 1.7 because that's rounded, but that's a mental note for us. All right, so let's go ahead and start graphing this. So let's go ahead and start with our center, -1, 0. All right. Then what I want to do is I want to, in the y direction, I want to move 2 units, right? 2 belongs with the y. 2 is associated with the y, radical 3 is associated with the x, all right? And judging from this equation, we know that this this hyperbola is going to have a transverse axis that is vertical, right? Because y is the positive. So this is going to open up and down. All right, so let's go ahead and move 2 units up. Just going to place a point there, and 2 units down. All right, next, my b, we haven't really talked about b yet. We're going to move in the opposite direction, in the left and right direction. So this is going to be from the center, I'm going to go 1.7. So this is where you have to kind of approximate. So 1.7. All right, and then what you want to do, it's better if you do this in pencil because you technically, it'd be nice to erase it towards the end, but that's okay for now. We're going to connect these points by making a box. All right, and what we want to do as best as you can, let me go grab my ruler. Actually, I'm going to try this. You really should have a ruler, but I didn't grab mine. So what you're going to do is you're going to actually make 2 diagonals, and you're going to go through the corners of that rectangle that you just made, and also through the center. Try to make those diagonals pretty long. All right, not bad for using a pencil as a ruler. And then we have the corners there. Oops, that one wasn't as good. All right, and here's what we want to do. Remember which ones are the vertices. All right, because of the equation, the vertices are these, because we know that the hyperbola opens up and down. So here's what we want to do: is we want our hyperbola. We can start here, but we want it to open as wide as these lines are allowing us to. So we don't want to make a little really thin U kind of shape right here. The reason that we just drew these diagonals is for it to guide how wide the branches should be. All right, so we should do something like this, but don't touch them because they're technically asymptotes. All right, and then the same thing down here. Make them wide, but don't touch those asymptotes. Okay, and then just the branches would be the final answer for your hyperbola. So it would be ideal if you made your rectangle here and your diagonals in pencil, and then maybe the actual branches in a different color, or just maybe a little bit, just press down on your pencil a little bit more. But this is how we graph a hyperbola. The only difference when we graph a hyperbola that opens left and right is that the equation would have x as the x fraction as the positive one and the y fraction as the negative one. And so what you would do is you would know, well, then these two have to be the vertices, and so you would draw them this way. So it is very possible for you to do all of this right, even make the rectangle correctly, the asymptotes correctly, but then you end up drawing the branch along the wrong set of points, right? So you might think these are the vertices for this example when actually these are the vertices. So you have to be really careful in your very last step that you know the orientation of the hyperbola, you know which ones are the vertices. And the vertices are always the ones farthest away from the center, right? It's the longer axis. That's why this is the transverse axis. These are 2 units away, whereas this is 1.7 units away. So you can also use that to help remind yourself.